Module 4 deals with micro electromechanical system MEMS and virtual instrumentation system. What are MEMS? MEMS are micro electromechanical system and it is a process technology used to create tiny integrated devices or systems that combine mechanical and electrical components. It is the integration of mechanical elements, sensors, actuators, and electronics on a common silicon substrate through microfabrication technology. And they are fabricated using integrated circuit, that is IC, and can range in size from a few micrometers to millimeters. These devices have the ability to sense, control, and actuate on the micro scale and generate effects on the macro scale. Where are MEMS? So we have seen MEMS in smartphones, tablets, cameras, gaming device and many other electronics have MEMS technology inside of them. Next is structure of MEMS. ICs can be thought as the brains of a system and MEMS augments it with the sensors and limbs. While the electronics are fabricated using integrated circuit, MEMS uses compatible micro machining process in addition to IC fabrication process that selectively etch away parts of the silicon wafer or add new structural layers to form the mechanical and electromechanical devices. These systems can sense, control, and actuate on micro scale and function individually or in arrays to generate effects on macro scale. And also these devices can replace bulky sensors and actuators with micron scale equivalents, and also it reduces cost, bulk and weight and power consumption while increasing performance, production, volume and functionality. So elements of MEMS include microstructures, microactuators, microsensors and microelectronics. Microelectromechanical systems are a class of devices characterized both by their small size and the manner in which these are made. It is a technology that in its most general form can be defined as miniaturized mechanical and electromechanical elements that are made using the techniques of microfabrication. These are made up of component sizes between 1 and 100 micrometers, and MEMS devices generally range in size from 20 micrometers to a millimeter, and this table shows length scales and their corresponding units and symbols. MEMS devices can vary from simple structures to extremely complex electromechanical system with multiple moving elements under the control of integrated microelectronics. So these are the components of microsystems. It basically include microstructures, microelectronics, microsensors and microactuators. So microsensors detect change in the system's environment by measuring mechanical, thermal, magnetic or electromagnetic information. And microelectronic process this information and signals the microactuators to react and create some form of changes to the environment. And MEMS actuators on electrostatic force to provide their actuation. Moving on to the advantage and disadvantages. Main advantage is it is cost and performance advantages are there. Then higher accuracy, sensitivity and selectivity. And main disadvantage is it is very complex design procedure and market value of components are high. Applications, as you all know, it can be used in disk drive heads, in inkjet printer heads, And in the medical field, it can be used in blood pressure sensor. Then in communication, it is used in fiber optic network components, and in defense also it is used, such as in arming systems. In automotive, it is used in airbag sensors, etc. So these are some of the applications of MEMS.